In this video I'm going to talk about pointers. A pointer is a compound type that points to another type. Like references we talked about before, they store the memory address of an object. A pointer gives you indirect access to that object, and the pointers can be assigned and reassigned and copied, and then they can be null, unlike references where you need to initialize them. A pointer, you don't need to initialize it, so it can be null. And the way we declare a pointer, we can just write int and then star and then whatever name you want. Let's call it p2. When we point to a variable, when the pointer points to a variable, let's say it's 2, then the way we dereference that pointer is by just using star and p2, the name of the pointer. And in this way you print what's the value of the original variable that the pointer points to. And you can do it in this way also. It's the same thing. And if you don't do that, you're gonna get the memory address of the original variable. As you can see, if we print them both, the addresses of them both, we will see that the pointer points to the same address of the variable 2. When we first declare a pointer, we should initialize it to null pointer. That's the modern way. Or we can initialize it to 0. It will behave the same way. Or you can use null, which is for older programs that use a preprocessor variable. And so when we print where p2 points to, we can see that it's 0, which means it's a null pointer. And we can, when we initialize the pointer to a null pointer, the modern way, we can get the same result. And even if when we initialize it to 0, we will get the same result. And there are multiple ways to store the address of another variable into that pointer. Doing this way, we can just write p2 equals the address of 2. And in this way, we just stored the address of number 2. And now we can see when we print it, it prints the address of that variable. And just so you can see it right here that it prints it. And if we have a null pointer, we can check if it's a null pointer by adding the exclamation mark and adding the variable name to check if it's a null pointer. Or you can check if it's initialized by doing the opposite. So I will use the one that we initialized before, this one, p2, and I will print that it's not null pointer. And here you can see that it's not null. It printed that p2 is not null pointer. And we can do it in another way to check if it's a null pointer by just adding the operator equals. If it equals to null pointer, then we print that it is a null pointer. And if we run the program, it will print p3 is null pointer. If we have an integer that happens to be 0, we can't really assign it to a pointer even if the value is 0. So even if it's 2, it's not gonna work neither. And why I said it's 0, because we could do it if it was a 0 literal, but not a variable that happens to have the value 0. Even if the pointer is null pointer, so we can do it. We should do it the same way we do for normal variables, to point to the address of that variable. And if we have 2 pointers, we can initialize a pointer or assign its value and assign where it points to another pointer, which means that they will point to the same parent, the same original object that the one we assigned to. If p2 points to the address of 2, and then we assigned p3 to the address that p2 is pointing towards, and we changed the value of p2 to, let's say, 5, both of the values will change. And obviously the original value will change also, because p2 points to the same variable. And if we change the value of p3, the same thing will happen. All of the values will change to number 5. When we use an initialized pointer, you will run into runtime crashes. So you should be careful when you declare pointers and how you use them and how you initialize them. And as you can see, it doesn't print anything useful. So it's really difficult to debug once you have some kind of pointer that points to an address that doesn't exist, as an example. And in this example, we have p2 as a null pointer. We assign it to 0. It's the same thing as not doing anything with it. Just keeping it this way. And we have p3 as the address of 0, which means that it points to number 0, but it's not a null pointer. And we assign p2 the value of it to 1. But we'll get a runtime crash because if the pointer is a null pointer, you can't assign a value to it. And you will run into a runtime crash. And you'll get in your editor, depending on your editor you're using, is that it will warn you that this local variable p2 might not be initialized. So code editors or IDEs will help you. And we can declare and initialize a variable of type double, and at the same line we can just add a comma and declare a double pointer that points to the object that we just declared. Like in references, we did the same thing. And this might be a little bit confusing. So we can declare a variable y and then declare it and initialize it to 0, and we can declare a pointer of type integer that points to y, and then we can change the value of x to 2, which will change y to 2 also. And then we can declare a reference that stores the address of the pointer that the pointer points to. So R2 will store the address of y. And if we look at the memory addresses of these variables, we can see that they all have the same memory address. The pointer points to the memory address, but the reference stores the memory address in it. And that's why if we change the value of one of them, all of them will change. So if we just reassign the value of R2 to 4, all of them will be 4. And lastly, we have the void pointer. It's a pointer that can point to any non-const type, and these pointers cannot be dereferenced, and we cannot do operations on them. Like, we cannot reassign the value. If we try to change the value of PV to 3, it will not allow us to do it. So basically, it can hold the address of any object, but the type of the object is unknown. And what we can do with it, we can pass it to a function or return it from a function, and we can compare it to other pointers. Like in this way, we can compare it to another pointer, which is the PD that we made them equal. And if we do the comparison equal operator, we can see that they print that they both equal each other. And since we don't know the type of it, we can't really do any operations on it. To test your understanding of pointers, you should solve this exercise. If we have variable I of type integer and we initialize a pointer that points to the address of I, and then what happens here in this operations? Write a comment what the result would be.